And what we're going to do, and this is an old syllabus, okay? Last summer I taught 214 rather than 202. And so it's been a while. It was fall 2014 was the last time that I taught 202. And it was a different book then, but it was the same author, so just a different edition. And hardly anything has changed, okay? So I'll pick up and go from here. I'll get this corrected because I've had no time to work on syllabi at all because we were canceling classes like crazy on the department chair, so it's just been nuts. Okay, so that'll get changed to summer 2017. It is Physics 2, General Physics 2, trigonometry based. It's a 4 credit hour course, 3 theory hours, 1 lab credit hours, even though we have basically 2 hours of lab, but because it's a 10-week course, it really is 3 hours of lab. So we're more than 4. In a fall spring term, it would be close to this: 3, 2, and 5. That's where it comes from. But since it's a summer term, which is only 10 weeks, then we're more theory hours, more lab hours, and more contact hours for still 4 credit hours. Okay. Don't let that confuse you. The class meeting days and times, evidently I changed this for somebody else, probably Dr. Bryant, and so I've taken all this out. It's Monday, Wednesday, let's see. For this class, 5:30 to 7:20. Now, tonight we'll do differently, but in the future, if I keep teaching it, which I assume I will. Technically, it says 5:30 to 7:20, and then 7:30 to 9. That's what it says on the thing, right? That's what it says on mine. Yeah. Now, in the future, if we want to take a break, we'll have that 10-minute break. But if you don't want to take the break, then we can go 9:20 to 8:50, and you can get out a little bit earlier. So it's just up to you whether you want to get out earlier or 10 minutes later. Take a break. You might really need a break. I don't know. We'll see. Tonight, we're going to have to use it all because we're getting up to such a late start. So Monday, Wednesday, 5:30 to 7:20, and A255, not 257. I'll get all this changed. And the lab is Monday, Wednesday. At least on the schedule, it says 7:30 to 9. If we want to change it to 7:20 to 8:50, we can change it. Okay? And it'll again be, and the lab will be either in this room in 253, which is the lab right next door here, or down in 259. Well, I'll let you know in class where we're going to have lab each time. Most of the time, I don't know. Can't say for sure. A lot of labs will be in here, some will be in the other places. Now, this is blank. I think I took all this out because I was giving it to somebody else. My name is Charles Fowler. If you haven't picked that up, that's my name. My contact policy, this is Dr. Bryant's. Okay, I changed it for him. My office is A265. Now, if you don't know the building, are any of you Lawson students? You're not, are you? You're all transit. Okay, you're right here in 255, right there. Okay, if you go out the door here, angle left, go down that little half flight of stairs there, go almost to the end of the hall. At the very end of the hall, there's a stairwell going down to the first floor, the library area, up to it actually doesn't go to the library, it's outside, or up to the 3rd floor. Right before, come in. Hey, you look familiar? Okay. You were psychopath, right? Yes. Okay. Just before you get to the stairway, right next to the mechanical room, in between that is 265, that office right there. That's 265. That's where my office is. Now, I'll get to this later. My email is cfowler@lawsonstate.edu. I'll get all this filled in, I hope, by Wednesday. Okay. My phone number is 929-33, I'm sorry, 929-3449. Okay. Give them the first part of the prefix of this number and then the suffix for my home number. That won't work. 929-3449. Okay, office hours. These are a mess. Okay. Oh, I forgot to mark you here. Let me get you. Megan, right?
Yes.
Okay. And you still go by Megan, right? Yes. Okay. Now, we were just talking about, we've only got 7 paid students in the class. And there is a question about whether they're going to let the class run with 7 paid students.
Is that 17?
Huh?
You said 17?
7. And they want 10. There's 3 more students who have registered, pre-registered, but they haven't paid. I don't know if they're going to take it or not. So, I think the thing that might keep it running is the fact that 2 students are not here now, but they're in my Physics 1 class that just got out, and they're also in Physics 2. And my Physics 1 class doesn't end until, 5:30? And the Physics 2 that Dr. Bryant teaches starts at 4. So they can't stay till 5:30 in mine and be at his at 4. Now, if they wanted to split the difference and catch up the labs or that kind of stuff, they can try to do that. So I'll have to talk with them on Wednesday and find out. But if they may, we don't know. For now, we're going to assume we're going to stay as a class. Okay? Though I don't know if the dean councils are going to act like that or not. But we'll worry about that later. Okay, I was going over the syllabus, and unfortunately, the syllabus has been destroyed. Somebody else was using it, and so all my information's gone. I'll get it back in there. Okay. I was just going to say my office hours. Here's my problem. Yeah, it's my problem, but in a small way, it might be a little bit of yours. My office hours on Monday and Wednesday. I come in about 7:45 in the morning, usually a little before that, but certainly by then. This morning I was then. We had really terrible rain, and I was a little later getting in than I wanted to, but I was here about 7:45. I have an 8 o'clock calculus class. It goes 8 to 10:40. Then I have a 20-minute break where I'm hoping to eat about half my lunch, but I didn't get to today. I had a granola bar. Okay, that's not your concern. And then at 11 to 1:40, I have calculus 2 class. And I have another 20-minute break, which I hope to be able to eat the second half of my lunch. Today I didn't get to, so I had another granola bar. Okay. And then I have a Physics 1 class that starts at 12, and it goes to 1:50, and then it starts at 2 and goes to 3:50, and then the lab is listed to be 4 to 5:30. Now, we might be able to move that up some to getting my time call crossed up, 3:50 to 5:20, okay? And then there'd be a 10-minute break before this class started. Today, I took the 10 minutes, or didn't take 5 minutes, went down and ate an apple because I only had 2 granola bars. So far, that's all the lunch I've had, 2 granola bars and an apple. But I can live. I got plenty to spare. Okay, so anyway, and then this class goes from 5:30 to 7:20, and they either from 7:20 to 8:50 or from 7:30 to 9. It's listed as 7:30 to 9. But I was just saying in the future, if you want to not have a 10-minute break between class and lab, we can do that and get through a little earlier. Okay. So, anyway. So, in other words, I have 2 20-minute breaks and 2 10-minute breaks. And that's the only breaks I have between office hours between 8 in the morning and 9 at night. Okay? That's all, folks. 2 20s and 2 10s. Okay? So that's not many office hours. Like today, I hardly made it down to the office. It's time to pick up a granola bar or pick up the apple. That was all the time I had in the office. Tuesdays and Thursdays are a little bit better. I have a differential equations 8 in the morning, 8 to 9:50, and then my linear algebra class did not make, so I have free from 10 until 12. But then at 12, I have a physical science class that goes 12 until 1:50, and then the lab 2 to 3:30. Okay, so I have office hours between 10 and 12 on Tuesday and Thursday, and then after 3:30. Now I can't tell you yet how long after 3:30. Since I have, I think it's about 13 and a half hour days, or 14 and a half hour days, 13 and a half hour days on Mondays and Wednesdays, something like that. And then to get 40 hours in the week, I can't be that long on Tuesday and Thursday. So I probably work a full day on Tuesday until some reasonable time, but then on Thursday I'll probably take off a little early. So I can't give you my end times until I sit down and work all this out and see how I can get the hours in. Okay, so those are office hours. My office is in on the Bessemer campus, A building, 265, not 255. Same as here. Okay. Course description. Now this is not something I made up. This was done by a committee of 2-year college schools and 4-year colleges and universities here in Alabama, public college and university. They agreed if we did this, they would give you credit. This is designed to cover, I should say, this course is designed to cover general physics using college algebra and basic trigonometry. Specific topics include wave motion, sound, light optics, electrostatics, circuits, magnetism, and modern physics. Okay? Now, I don't see any of you with a book yet. Do any of you have a book already? Okay. And since this is Physics 2, I doubt if you're taking another. Do you have any physics book at home, like one you use for Physics 1? None of you have that. So I was going to say, if you still have it, don't buy a new one, because I can show you how this is. So let me just briefly talk about where we're going here. I'm going to use the table of contents. It's easier to do than coming through the book. Notice here it starts with wave motion and sound. Now, they put a comma between, but basically this is the same chapter. This topic, this new book that we got, this is a new edition. I haven't taught from this one. I had the previous edition back in 2014 when I taught it. They're no longer called chapters. They're called topics. Topic 14 is sound, which includes waves. Okay? So topic 14 is where we're going to start, and that's wave motion and sound. Now, light optics is later, so we're going to cover it, but not yet. Then we do electrostatics. Okay? Now, electrostatics is covered in topic 15, 16, and 17. Okay? That's electrostatics. Then circuits is topic 18. Magnetism is topic 19. And then they say modern physics. Okay? And modern physics is basically topic 26, relativity. But before we get there, let's back up and do the light optics, and that would be topic 22. I'm a little perplexed with what to do this. I really want to do topic 20 and 21 also, but I don't know if we're going to have time for it. So we'll have to see when we get there. So we'll definitely do topic 22, which is reflections and reflection of light. And I'd like to do 23 as well, mirrors and lenses. and I don't know if we'll have time to do both. That would be light optics. And then modern physics would be topic 26, which would be relativity. I don't think we're going to have time to do quantum physics and atomic physics or anything else. If we even get to relativity, I think we'll be lucky. Because that's a lot of chapters or topics. 14, 15, 16, 17, 18, 19, 22 at least. And 26. That's 8 chapters in 10 weeks. That's going to be pushing it. And if we have a chance, we'd like to do topic 23 as well. That's mirrors and lenses. I think that's such a sort of a fun chapter to do, but I don't know if we'll have a chance to. Okay? So, I need to get hopping and not talking so much. Okay, so that basically shows you how the course description matches the book. All the topics are done, but not necessarily in the same order. The light optics comes down here between magnetism and modern physics. Okay? Prerequisites, Physics 201. Now, I know one of you had this, and did any of you others? Yeah. Didn't you have it last summer too? Yeah, both of you did. Y'all had it somewhere else, right? Where? Somewhere else, not here. Right. I know you haven't had unit classes.
I took it at UAB.
What's that?
I took it at UAB.
Okay, all right. Co-requisites, there aren't any. The textbook, now, this is a change too from 2014. We're no longer using Knight, Jones, and Field college physics. We went back to Survey and Buell, which is college physics also, which is not a strategic approach. And this, by the way, is the 11th edition, not the 3rd edition. I'll get all those changes done. It's no longer Pearson, it is now Cengage Learning, okay? And the year is much more recent than that, okay? Students are expected to bring the text, paper, and pencil to class. Now, if you prefer pen, that's fine, I don't care. We will be doing problems in class, so be sure to bring paper, pen, and pencil so you can do those in class. Calculators are permitted, in fact, highly encouraged. Now, what kind of calculator? A scientific will do all that you really need, but if you already have a graphing calculator, that may do some of the things and help you see things a little bit better. Okay? Now, this paragraph on Blackboard, I think that's one of the reasons the other two students left. One of them heard it twice today already, so I don't want to harp on this too much. Since most of you are not from Lawson, but 2 of you have been here before, are you familiar with Blackboard? All of you? Okay, I won't have to say anything about how to do this. I really don't like this paragraph though. It says all state community college students must be trained in Blackboard and use Blackboard daily to gain access to vital course information such as the syllabus. You will read the syllabus every day, won't you? Sundays and Saturdays included? Not likely. Okay, so I think this is a bit overstated. Handouts, if I'm giving you a handout, I'm going to hand them out to you. I'm not going to put them on Blackboard. Okay? PowerPoint shows, yes, I'll put them there. By the way, they're not there yet, so don't expect them there yet. But let me tell you where on Blackboard to go. If you get on Blackboard in this course, when you're there at the home page, there's a block in the upper left corner here that has a bunch of, I think they're blue tabs. They show up blue on the instructor side. I don't know what they do on the student side. But about the second or third of those tabs is one called Content. And under Content, I'm going to put the syllabus when I get it correct. And of course, I've got a lot of corrections to make on this one. Okay? I will also put the research paper instructions. Okay? So that's going to be an assignment I'll put out there on Blackboard. Okay? I will also put my locator card that shows when I'm in class, when I'm not in class, when I'm on campus, not on campus, that kind of stuff. That will be there. Okay? All under Content. I will then put all the PowerPoint shows. Now, here's sort of a problem, okay? The DVD that I have is from the previous edition, okay? I think both of these are. And when I say both, I'll explain that in a minute. Yeah. No. Yeah, there are 2 editions of code, 9th edition. I don't know if we have the 10th edition. I think what they've done is gone to having online PowerPoints. And I haven't logged on to get those yet. So if I need to, I will. But frankly, from what I've seen so far, nothing has changed. The only reason they have new editions is so they can sell more new books. Because the publishers don't make money on used books, so about every 3 or 4 years they do a new book, new edition. Sometimes less often than that. So I think I can still live with those. If I can, I will. If not, I'll get the new ones. Okay, PowerPoint shows. Now, you're actually going to have that twice. They will be, each of these chapters will have a PowerPoint show under content in static form. You can look and see everything I can see, but it's just static. It just sits there. You can see what the PowerPoints are. The other place they're going to be is on the YouTube videos. Because like I said, I'm going to record these, upload them, send them to YouTube, put them in a playlist, and I'll give you the link to playlist. You're going to be able to access that link through content under Blackboard. Okay? So it'll also be there, but it'll be in a different location. Each one of them will be here under the YouTube link. That's where you'll get each class. And I use the PowerPoint shows in class. Activities. Now, I don't know of any specific activities we're going to have, so I'm not going to post anything. If there are any that the school posts, they may be out there. So don't expect me to post anything new there. Assignments, like I said, I'll put the research paper assignment out there. It's not there yet, but I'll put it there as soon as I get a few minor changes done to it. And at the end of every class, I'll stop and let you know any problems at the end of the chapter that you can work on for next time. But I'm not going to type them out and put them on Blackboard under an announcement or something. You'll have to go to the YouTube link and hear what those assignments are. Okay? So they will be on Blackboard, but they'll be through YouTube. Announcements, I'm probably not going to make any there, except for possibly one. Okay? It really irritates me. There was an announcement of a special National Science Foundation meeting that was going on, and we had an option of they sent me the announcement and said, if you're interested, send a team of 3 to 4 people from your school, and here are your options. And they gave us 3 schools and 3 times we could do. So I sent to my up the chain of command and said, I'd be willing to go to this, especially if we go to Spelman College in Atlanta on a certain Friday and Saturday in June. That wouldn't interfere with classes. That's what I'd like to do. Well, the vice president got back to me because I had emailed him when I responded. He got back to me and thanked me for being willing to go, and said, but we would rather go to the one that's down in New Orleans on a Monday and Tuesday. I said, well, that's going to interfere with classes. He said, well, we didn't want to interfere with anyone's weekend. Well, that's the administrator thinking, I don't want to mess with the weekend, whereas an instructor thinks, I don't want to mess with classes. So I don't know where we're going. Hopefully we'll go to Spelman because they assign us where to go. He put in a request for the other. But if we do, then that means I'm going to miss that Monday. I hate it because we're already going to miss, the good news, bad news coming up this weekend, right? The good news is Monday's a holiday, Memorial Day. The bad news, of course, is we won't meet. Okay, sorry about that. So now a 10-week term becomes
Is that good news?
That's the bad news that we're not meeting. You weren't paying attention, were you? Okay. So that makes it a 9.5-week term, and then if I have to miss a Monday to go to that meeting, that makes it a 9-week term. So I'm really hacked off about that. Can't do anything about Memorial Day, but what I plan to do for that day I'll miss because of the meeting is try to make it up to you on the Tuesday and Thursday. So if you can come that day, fine. If not, I'll just record it. And I'll record whatever we would have done in class, at least for the lecture part, an hour and 50 minutes of lecture for that. And I'll set it at a time when most of you can come. Okay. So, anyway, that's how we'll go with that. Okay. Announcements, grades. As soon as you turn stuff in, guess what? I'm not going to grade it that night. Okay? If we get out at 9, I'm going home, I'm eating supper and going to bed. Okay? And then I've got an 8 o'clock class the next morning, so the earliest I'd be able to grade it would be starting at 10 the next morning. Hopefully I can either grade it then or after my physical science at 3:30. Hopefully I can get it graded and in Blackboard by the next day, at least for the month of May and June. Once July gets here, however, we start registering, pre-registering for fall, and the last time I checked, I had about 450 students that I was listed as their advisor. And not all of them come see me, most of them register online, but a lot do, and therefore a lot of my office hours on Tuesday, Thursday are going to get eaten up by advising and registering students. And therefore, it's probably going to be the weekend before I'm going to be able to get much of the grading done. So don't expect the grades. The first part, hopefully I'll get them in on time. The second part, who knows when I'll get them in. I'll get them as soon as I can. Now, I do not like this next sentence. Failure to use Blackboard could severely damage your ability to pass the course. That's so negative. If I were writing this but they don't let me change it, I would say the proper use of Blackboard could enhance your ability to do well in the course. It's much more positive, I think, closer to reality. Says, see the schedule book inside cover and determine. We don't have a schedule book. We haven't had one in years, and yet they don't change this. Ridiculous. They won't let me change it. Students should always check the Blackboard announcement page prior to coming to class. Why would they put that sentence in there? What's implied there? Well, put it on that in case I'm going to cancel class that day. That's the only reason that I could see that you would say students should always check Blackboard announcements page prior to coming to class, comma, in case the instructor is canceled. Guess what, folks? I'm not going to cancel any class that I can possibly avoid canceling. I'm going to be here. I'm here all day. Unless I've completely lost my voice or my mind or something else, I'm going to be here. If I know I'm not going to be here, I'm going to let you know way ahead of time. So you don't need to worry. I'll be here. Now, if something were to happen, an emergency or something, I'm probably not going to have a chance to put it in National Blackboard. So, whatever. Okay. I'm sort of not too pleased with that statement. Okay, as you can tell. All right, here's the course student learning outcomes. Students will be able to solve problems involving waves and sound. Again, that's topic 15. Okay? And you'll see this show up a little bit later too, but I'll go over it again. Topic 15. Students will be able to solve problems involving optics. Now that's going to be much later, topic 24. I'm sorry, topic 22. Maybe 23, but we'll see. I'm going to change the order of those, I think. Okay? Students will be able to solve problems involving electrostatics, electric fields and forces, electric potential. Basically, that's topics 15, 16, and 17. Okay? Students will, I'll change some of the wording in that too. Student learning outcome number 4. Students will be able to solve problems involving current, resistance, and circuits. Well, if I leave that there, I will change, however, that's going to be topic 18 basically. I'm going to change the wording. Students will be able to solve problems involving magnetism, electromagnetic induction, electromagnetic waves, and AC electricity. If we did all those, that would be topics 19, 20, and 21. I don't think we're going to have time to do all 3, so I may back off from that and just do magnetism. Well, that's all the courses we can call for. Number 6, students will be able to solve problems involving modern physics. That's topic number 26, relativity. Students will be able to write a library internet-based physics research paper and one on computer application increases your understanding of physics. We'll talk about that in the next thing. Students will be able to conduct laboratory experiments and write the results. And I also probably will put in there work collaboratively, because now here we have a class of no more than 10. It looks like at least 7. So basically you're going to be in lab groups of 2 or 3, okay? So it's going to be pretty small labs, but that's sort of good because it gives us more time. Now again, this is based on the previous book, not this book. So I'll go over these competencies here. I think I just said them, but just in case so you can follow. And I'll change the order of them too. The first one, waves and sounds, that's topic number 14, topic 14. And I'll change the order of this and move straight to electrostatics, and that will be topic 15, topic 16, and topic 17. Okay? Current, that will be topic 18. Magnetism, topic 19. Probably skip the next 2. Light and optics, topic 22, maybe 23, and modern physics, topic 26. So I will get these updated here, and then we'll have the library internet research paper done and comprehensive final exam done. And those who were in my class before, you remember how that is: the last test and then the comprehensive final. Short tests, usually 10 questions each, somewhere around there, but they're all problems, not just short answers. So you do have a little bit of work to do with each of those. Okay, how will I evaluate all this that you're doing? Someone else wrote this, set up this syllabus. I don't see why that sentence is even in here. Student achievement will be assessed and evaluated by several measures. First, your laboratory assignments. Secondly, a library internet research assignment. And then topic test and a final exam. Numerical grades will be assigned to each. All the items assessed will be used in calculating the final grade. A scale of 0 to 100 will be used and weighted as follows. The average on the laboratory assignments will count as 25% of your final grade. Why? Well, if you remember, it's a 4-hour course, 3 hours of theory, 1 hour is lab. That's a quarter of the time, or a credit, so that's a quarter that you'll get. 25% will be based on the lab. Labs are pretty important. At least one laboratory assignment may be dropped, okay? The library or research internet application assignment will be counted as a test, and that cannot be dropped. So you've got to do the paper, or else you get a 0. One chapter test score may be dropped, and now they're no longer chapters, they're topics. One topic test score may be dropped. Okay? The test average is computed from the library research assignment and the remaining tests. The comprehensive final will count either as 1 or 2 chapter tests. Let me tell you now, it'll be 1 chapter test. Because I'm not going to give you a big long one. We'll have the final chapter test and the comprehensive. In fact, at the time I may back off and only give you the final chapter test. But the last, whatever your last test is, whether it's comprehensive or not, it cannot be dropped either. And then your average based on what we did there, and I'll fill in a little bit more there. These are all based on 100 points. That average that you get here, I'll take 75% of that and add it to the 25% of that. And by the way, how I do the labs, I base them on 25 points each. So whatever your lab average is, that's how many points get added to the 75% of your test scores, test average. And then anything that's in the 90s are A's, 80s are B's, 70s are C's, don't go down below that, okay? These won't transfer back to your home school. You won't get credit for them here, so don't go there, okay? If you cannot attend all the classes and get the labs done and get your tests done and are going to wind up messing up down here and getting a D or an F, it's far better to withdraw than to get a D or an F. Now, sure, there could be some financial aid implications of withdrawing, but guess what? The same implications happen with D or F, exactly the same. So therefore, a D or an F hurts your grade point average, a withdrawal does not. So I see no choice. If you don't get a D or an F, it looks like there's no way around it, withdraw. Take a W, take it later, okay? If you don't, and you make a D or an F, you're going to have to take it later anyway and mess up your grade point average at the same time. Now this next statement here, makeup work, okay? It does have some validity when it comes to labs. If you're not here for a lab, you're going to have to make it up. Now, here's what I suggest. If you know you're not going to be here, get a classmate to pick up a lab for you, and then maybe you can share data from him or her and then work the lab yourself. If you do want to physically make it up, I have no time on Mondays and Wednesdays. I'm in class all except 2 20-minute periods and 2 10-minute periods between labs and classes. There's no time to make up a lab then. So the only time you can make up a lab is to come in on a Tuesday or a Thursday. I don't know if y'all are even going to be on campus then. So please, if you are going to miss a lab, please work out some way. I'll help you as much as I can, but it's going to have to be on a Tuesday or Thursday. Okay? So work it out with a friend or something. Test. I give the test. You have, and oh, I forgot to ask this. Do y'all prefer in-class test or take-home test? Really? Wow, what a surprise. Okay. I've never had that. No, of course. That makes sense. Okay. I'm not surprised. Okay. Therefore, when I do give a test, if you're absent that day, you got to get it as soon as you can, or get a friend to pick one up for you. Okay? And then I would request that you get the labs returned and the test returned, if possible, within a week. Now, there's two reasons two reasons I give you a week. One is that if there's something on that you don't understand, you always have one more class period to ask me questions. Okay, now let's back off a little there. The questions you're allowed to ask would be something like, I don't understand what this means, what you mean by this. That would be legitimate. Not, I don't know how to work this, can you work this problem? No, that's what the test is for. The test is to see if you know how to work the problem, okay? So what you are allowed to ask, at the end of every chapter, there are problems. The test questions are written, I think, by the same people who write those problems, so they're pretty close to being equivalent. If you can find any problem in the book that's similar to a test question, I'll work anything in the book as long as it's not the same question. I haven't run into any of those, but this is the first time I've used this text, this edition of the text, so I don't think they have any of those, but I will work any problem that's in the book that's similar to a test question, but not the same. So you are allowed to ask that question. I'll be glad to work any problem in the book, but not your test question, because that's not a graded question. Okay, so that's why I give you a week. You always have one class to ask questions. And the other reason, some of you may work, I think you do, right? That always gives you a weekend that you can work on your test and lab if you need that. Now, a lot of the labs you probably will be able to finish the day out of the lab, turn them in that night. You don't have to, but you can if you finish it, and that way I can get it graded. Now, I say try to get it in within a week. Here's the main reason I do that. I told you why I give you a week, so you have a chance to ask questions and you have a weekend in between. But the reason I really would like them back as close to a week as possible, I can't return the other tests or labs to the other students until I get them all in. And for you to be the only one hanging on to it, just not getting around to it, or fiddling around, procrastinating and not doing it, the other students can't get feedback. Now you can come see them anytime, see what you missed, but you can't take it home and figure out how you missed it. I'll help as much as I can. So please try to get the things in within a week so I can get them back to you. Now if you need more time, no problem. Take as much time as you need, but I'd really rather you not have like 2 or 3 tests out at the same time. Try to get one done, because once that happens, it just snowballs on you and you get just totally swamped. So try to get them in within that week if you can. But if not, yeah, take an extra day or 2 if you need, but get them in as soon as possible. So then I can get them back to you as soon as possible. Okay? So that's about makeup work. If you miss a test or a lab, still I'd like you to get it back to me as soon as possible. You're just lost another day or 2 before you can get it back. So please try to get it back. Lateness, I'm going to try to start class every day on time. As you saw today, the other class was leaving right at the same time yours is starting. That's how they're going to set up. I'm going to try to skip the break in the other one and end 10 minutes early so I can run down and get a drink of water, and that kind of stuff. But I'll try to start as soon as close to on time. Today's been crazy. First day of class always is. The statement on discrimination and harassment. I like to throw one other term in there because it's real, current. Bullying. That's a form to me of harassment or discrimination. Basically, here's the bottom line. This will not be tolerated. These things are never tolerated. Okay? In fact, I've been here close to 20 years, I think. Maybe over, but I think it's more like that. I'm ending my 20th year, and so far in 20 years I cannot think of a single thing that would fall under this. I can think of a few things that were close, but not exact. But I've not seen discrimination. Now, I'm not saying it hasn't happened. I hope it hasn't happened, but I've not seen it. And harassment, I haven't seen that either. I did see something, I didn't see it. I heard about something really stupid. We have an automotive program here, really nice, a really good automotive program, but it draws mostly very young kids, mostly guys, a few gals. Gals are usually pretty serious, okay? And most of the guys are really good students by and large. But I can remember one year, one student in particular, his dad was making him go to college, and he chose automotive mechanics because it sounded like the most fun thing to do. But he wasn't pretty serious about it at all. He should have still been in junior high in my mind. He was that immature. And one day during lunch hour, he just decided to walk across people's cars in the parking lot. Someone saw him, yanked him out of there, took him to the dean's office. He had a very fair, I'm sure, but also pretty brief hearing. He was off campus, never to be seen again, okay? That's what I mean. We don't tolerate any kind of things like this. Now, you will be given a fair hearing. We're not going to rush anything through. That was sort of rushed, but he deserved it. But yeah, any practice or behavior that constitutes harassment or discrimination or bullying, any of that kind of stuff, is against state board policy. It's against everything we believe in. Now, on the other hand, I want to ask you something. People aren't going to do that in front of me. I'm pretty sure no one's that stupid, okay? So, if it is happening and you see it, or even sense it, you think it might be happening, let us know about it so we can get to the bottom of it. If we find out it is, it will be dealt with, nipped in the proverbial bud, so to speak, and we don't want it to happen here. We're against it, okay? But people will be given a fair hearing. Okay, Americans with Disability Act. I've got to update this. There's some things in here, like she's no longer here. There's someone in her place. So I'll get this updated. But basically, if you have a disability, please let either me know, but more likely Dr. Renee. It's now Dr. Renee. She's her doctor since this was printed. And I'm going to update this. Please let her know. Bring in the documentation. don't bring it to me. You can, but I'll turn it right over to Dr. Herndon. But she'll need to meet with you. She'll determine what kind of accommodation you need. She'll get the information back to us, and from that point on, you will be given whatever accommodation you need. Now, if you feel like it's not given a fair shake on it, we'll help you write us up. We are serious about doing this. Frankly, I mean, I'm hard of hearing. If y'all don't know that, haven't noticed it yet, that's why I talk so loud and I ask you to repeat things. I can't hear well. So I'm sensitive to this kind of stuff, but I would be in favor of it even if I weren't. But my goal is to help you learn. Whatever it takes to help you learn, I want to do that. So that basically is that. The course calendar, or also called the academic calendar, is on our website. And on the website, there's a bunch of blue tabs at the top of the website page. Somewhere right over here, somewhere you'll see college calendar or academic calendar. Click there, you'll see all the important dates. I'll put it. Just go there, and that's a lot more efficient. Once I get all this updated and the correct information in, I got a lot to do on this one. I didn't know this was in such bad shape. Then I'll tell you that it's out there on Blackboard. When you see it, you can either type in your name and date and email me that you've acknowledged receiving it and understand it, or you can print this page and sign and print your name and type and print the date and then give it to me. Either one you want to do. I'll let you know when it's updated. I would like to say I'll have it done by next Wednesday, but I've got a lot to do between now and then. I think we've got to do contracts and all sorts of things, but I'll try to get it done by next Wednesday. But any questions on the syllabus before we move on to something else? Okay. Sorry, this is taking way longer than I intended it to take. Okay. Next thing I want to talk about, and I know two of you have been in my class before, is that right? Only two? Okay. Every class has a research paper, you might remember fondly, right? Here are the general instructions for that, and I'll update these and put these on Blackboard as well. They're not there yet. You check in to choose your topic within the scope of Physics 2. Anything to do with sound, anything to do with electricity, anything to do with magnetism, anything to do with light, anything to do with modern physics. There's tons of things out there. Literally, and there's only 10 people in the class at most, maybe only 7. Lots of topics there. You pick your topic. You can write on a person. Any one of those areas, there's probably half a dozen to a dozen people you could write on in that area. Any theory, and we'll talk about several theories. You can look through the book and see them ahead of time. Any theory you want to talk about. Any phenomena that pertains to any of those areas. Sound, light, supersonic sound, bending of light, refraction, anything you want to write on, that would be legitimate. An application of any of the stuff we do, electricity, magnetism, any of that stuff. Pick something that you are familiar with or interested in. I'll give you an example. You don't have to use this one. Well, I'll wait a minute before I do that. Okay, any other such topic about which you have an interest that relates to this course. Okay? Or, and now I've added this, it can be an internet application or demonstration which you find useful for the class. Now, we will talk about, not in great detail, but we will mention, and this is the one I was going to say, a Van de Graaff generator. Are y'all familiar with that? I bet you've seen one, whether you knew what it was or not. Big stainless steel ball that they run a belt around, and it builds up charge. And if they have someone standing with a hand on that, their hair all stands up and gets far apart. You've probably seen that done before. Well, one of the students read about that, remembered, I think, that he had seen a television show about that. I can't remember the name of the show. It wasn't Mythbusters, but it was something like that. And the folks, some strange name of the show. I've never seen the show, but I've heard people talk about it a lot. But anyway, he got we went to the YouTube video that they had done about that show, and he wrote about the YouTube video. They actually built a Van de Graaff generator. They went into some of the problems they ran into and some of the science they learned about it and that kind of stuff. It was a really good paper, okay? Because he found an internet application, a YouTube video, I think it was, that demonstrated how you build a Van de Graaff generator. And that helped him understand it better than just a little paragraph or so we had in the text. And he had seen them used and he wanted to find out more. I say he, it could have been a she, okay? Okay, so anything like that you want to use, you can do. Now, what I'd like you to do either tonight or next week, and next week we only have Wednesday, remember, is write on a piece of paper your name. That's pretty easy, right? And the topic, at least the one you selected to begin looking into. You can pick anything that we cover in here. Like I said, there's tons of topics and only 7 or 10 students. Okay? Now, you'll need at least one, but 2 or more are better, outside sources for your paper. Okay? Now, what does that mean? It can be any book, journal, magazine, article, newspaper, anything you can find in the library. Now, here's the kicker here, or any legitimate source you found on the internet. I tell each of my classes, it's probably some of you are tired of hearing me, in my lifetime, started in 1951, the internet has been developed. So I would have to say, what has occurred during my lifetime that's the most incredible thing to me? The internet. Unbelievable what you can do with that. Okay? 2 problems. 2 big problems anyway that I know about. There may be many others. One, at least, and I think way more than half of the stuff out there is total garbage. Okay? The other problem, sometimes we don't know which half it is. So be careful with what you get off the internet. If you have any doubt, run it by me. We'll look at it together and I'll say, hey, you know, that sounds suspicious. I've never heard of these guys. I don't see where anyone else is, referencing them or documented this. It sounds like this could be a spoof. Okay? Or, no, that looks great. That's one of the best I've seen. So run it by me if you have any doubt. The textbook, now the textbook has periodically things like historical perspectives, a little blurb on various people. That may give you an idea for the topic. That can't be your outside source. The textbook is inside the class. I want to get you out of the book into the real world or the library or somewhere so you see outside application of this. Now, what about the paper? It has to be at least 1 word processed page of text. What do I mean by that? Okay? You get to choose whatever format you use. And a lot of students, and you don't have to do this or not do it, doesn't matter to me, have something where you have a big header at the top up here, several lines and stuff, then maybe a triple space and then the title, maybe another triple space, and finally they start writing the paper down here, right? 1 page of text then is going to go to the bottom of this page, and then on the next sheet of paper, come down at least that bar. That's a page of text. Now this is with standard margins and all that kind of stuff. Now, I do want it double spaced. This happens to be single spaced here. I want you to double space, so that makes it a lot less that you have to write. And I want you to use 12 pitch or 12 point font, whichever you call that. I don't want any real tiny that it's hard for me to read, nor do I want any real big that 5 words take up a page. That's not going to be your paper. So keep it this. I don't care which font you use, as long as I can read it. I don't read hieroglyphics. I don't read Old English. I don't read Cyrillic or Greek or any of those things. So be reasonable and make it some good readable font. Most word processing packages, for some reason, default to Times New Roman. Fine, I don't care. I did this in Arial. Fine, I don't care. Courier is another one. Copied off of a typewriter. Yeah, that was the old font of the typewriter. Fine. There are tons and tons of great fonts out there, very readable. Just pick one and go with it. Now, I have seen people they start off, say, in Arial, but then somewhere in the middle of this paragraph, suddenly it becomes Times New Roman or something else. I can tell the difference. Why couldn't you? You don't lose points if you do something silly like that. Now, I said it needs to be at least 1 page of text. I encourage you to try to keep it less than 2 pages. So you shoot for between 1 and 2 pages of text. But what I don't want to do is discourage you. If you find a topic, a person, a phenomenon, an application that you really love and you are writing and it goes over 2 pages, no problem. I do not take off points for it being too long. I do take off points for it being too short. But let me say this as well. It doesn't happen often, but it's happened a couple of times, maybe 2 or 3 times in the last 15 years that I've been doing this, that I've had a student that, in my mind, basically was trying to swamp me with quantity rather than impress me with quality. And when you do that, it's not a good idea. Okay? I don't think any of you would do this, but I have seen this happen. They think if they write more, they're going to get a better grade. Here's how I grade your papers. When you turn it in, it's a 100-point paper. I can hear you now say, don't read it then. No, I'm going to read it, okay? And if I read it, and as I read it, if I find errors, you start losing points, okay? Now, you turn it into me at 15 pages of total garbage with lots and lots of errors. Just think how many points you're losing. It's going to get pretty nasty quickly. So I'm much more interested in quality paper. If it's 1 to 2 pages, fine. If it's 3 or 4 pages, if it's a good paper, I'm going to enjoy reading it. So hit me with it. That's fine. But if it's garbage and you're just trying to impress me by putting more and more garbage, you're not going to wind up with a good score. No matter what, if it's garbage, it's not going to be good. Okay. You can use any standard format for your paper. Now, a lot of English classes teach MLA, Modern Language Association format. If you're familiar with that, you like that, you're used to it, fine, go for it. A lot of scientific organizations go with something like called APA, the American Psychological Association. They early on came up with a really neat, clean, useful, clear format, and lots of people like it, and lots of people use ASA. They say, use ASA, it's standard. I mean APA, sorry. I'm a member of a group called ASA, that's what I was thinking of, but they have their own format too. When I was in grad school and we had to do I had to do a research methods course, that professor insisted we use CBE format, that's Council of Biological Editors. I don't even know if they use that anymore, that's a long time ago. But there's lots of different formats out there. I don't care which one you use, but once you pick one, be consistent to that format. So if you start blocking paragraphs, block all your paragraphs. If you start indenting your paragraph, indent all your paragraphs. If you use one format, I've seen this happen, not often, but I've seen it happen. If someone makes a reference to a source up here, opens a parenthesis, puts author's name, comma, year of publication. Close, and I can go back to the work cited and see exactly what he's talking about. But then later down here, he refers to a different source, but it's the same type of source, and he opens parentheses, puts the title, comma, page number. Well, that's being inconsistent. Now, I think I know what happened. This source that he was quoting here used this format, and this one he was using here was using a different format. It's fine for your sources to have different formats. I want you to pick your format and keep consistent with it, okay? So be careful. Pay attention to what you're doing, okay? Now, I know that if you're referencing a book, that is going to look different from a journal or an article from the newspaper. I understand that. They will look different. But this was one that there were 2 very similar references, but their citations were 2 formats, 2 different formats. So that's not good. Now, spelling, grammar, sentence structure, all those types of errors that English instructors will take off, I'll take off too, okay? I may not be quite as gruesome with it as they are sometimes, but I will take off, okay? But guess what? Every word processing package I know about has spell check on it. Most of them have grammar check, okay? Use them. Now, I don't always agree with either of those, like some proper nouns, or spelled a certain way, and just because spell check doesn't like it. No, I want it, I will spell it correctly. And sometimes grammar check wants you to do something that I really don't think is right, so I will not always agree with them, but I'll at least look at them and make sure that what I'm doing is correct. Now, another thing is use good proofreading. Now, I give this example because it's the best example I can remember. It was my high school English teacher, and she had this way of saying, she assigned some pretty massive, not massive, but pretty involved research papers or other papers. And here's, I remember when she was telling us how to do this, it was the best advice I've heard. She said, get the paper done as early as you can, as soon as you can. And she said, let it set. And she used the term, let it rest for a couple of days. Let it rest. Interesting phrase. Maybe over a weekend. Then she said, pick it up several days later and read it again with, and again she used the term, with fresh eyes. Okay? Now what she meant by that, what I interpreted by that, type, read, type, read, read. That's not proofreading. Okay? Yeah, it is a form of proofreading, but if you're reading it right after you do it, you know what you're trying to say, so it tells you that's what you're trying to say. If you let it rest for a few days and pick it up with fresh eyes, and you start reading that and reading it as not trying to remember what you had meant to say, but reading it just like you'd never seen it before. What did I mean here? Okay? If you ask yourself that, I'm going to be asking the same question. So let it rest, read it with fresh eyes, and if something doesn't make sense, the odds are it really doesn't. When you were typing it, it made sense because you knew what you were thinking. Now when you read it later, you don't remember what your thought process was. If you can't reconstruct that, you can probably write it better than that. Okay? So use good proofreading. Content also matters, so I'm not just taking off grammar points. If you have something inconsistent, now let's pick something in this class. Like if you're talking about the Van de Graaff generator and you talk about the belt, that it's producing an electric field, whereas really it's just moving charges around, I'm going to pick up and know that's not quite right. That's probably a terrible example, but let me give you one that's probably easier. You wouldn't use this in this course, but I've seen it in several math courses, writing on the Pythagorean theorem and stating it incorrectly. I mean, I know what it's supposed to be. I've seen people put the signs in the wrong places. Oh, that's not right. Anything such as that. So content also matters. For instance, people writing about people. If you write about the first electric motor was created in 1942. No, that's not right. I think it was 1942. Yeah, I'm going. The content does matter. So if you have inconsistency, you also lose points there. Now, I keep talking about losing points. I want you to have good papers, but I want it to be good papers. Okay. The paper is due by the last day of class before final examination week. But I'd rather you not turn it in that week. I'd rather you get started today. That's why I asked you to, did I mention that? Writing on a piece of paper? I skipped that, didn't I? You're right. Did I talk about this?
Yeah, you said it.
Okay, yeah. If you'll do that either this week or next week. And by the way, here's what I forgot to say. This is why I forgot that totally. This is my fourth time going through this today. I can't remember what I said or not. If you want to, rather than just writing only those two things on a piece of paper, that's all I need, okay? But if you want to do this, you can also give it, and let me give you the background first. It has nothing to do with the paper. But it has happened maybe 2 or 3 times in the last several years. Not very frequently, but just a couple of times in the last several years. I've had either a frantic phone call from some administrator or somebody here at the college, or they've actually come running to my door and say, is thus and so in your class? I said, oh yeah, they're in my blah, blah, blah class. She said, we're trying to get in touch with them, and the number in the system isn't working. Now, that could be because it got in the system a year or two ago and you changed the numbers, but you didn't tell them, or that when someone entered it in the system, they transposed 2 digits, and so it's not working. Or you changed plans, or whatever, okay. And they're trying to get in touch with you. Something has happened that's sort of an emergency nature, and they need to get in touch with you. Then if I have your most current number, I'll give it to them. I won't give it to another student. I won't give it to Joe Blow off the street. Only someone here at the college that has a legitimate reason to need it. It's the only person I'm going to share it with. So if you want to give me that, because I'm the person they're going to come to, say, they're in your class, do you have a way to get in contact with them? So if you give me that, I will. The odds are I will never be contacting you there, but I might. But I'll have it if I need it. But you don't have to give me anything. But if your very best phone number happens to be a cell number, like I see several of you have, okay, fine. That's good. But if there's a chance that cell phone could die or be run over by a truck or left at home or lost somewhere or be in the seat of your car and you can't hear it ringing or something, or on silent even, and there's another good backup number that someone could reach you, like Mama's landline or something like that, then you can give me that. You don't have to. None of these are required, but if you choose to, you can. Or if some of you work and you're not supposed to take cell calls at work, which does happen some places, but you can receive an incoming phone call at the company, then in that case, you can give me your work number, okay? I don't need any of these, nor all of these, but you can give me as many as you choose to. You can give me 0, 1, 2, or 3. It's not going to bother me at all. But if you give it to me, then if there is a need, I can provide that need. But that's not required. So that's the other thing you can write on that piece of paper. Okay, sorry. I just happened to think I didn't know that. All I had to do. Okay, so I'd rather you not turn it in the last week of class. Get started on it early. Get it done early. That's why I asked you to write it on a piece of paper so you can start thinking about it now. And maybe you got a whole week till we meet again, right? So get working on it. Use this week that you have to, guess what? You'll never have more time to do it than you do right now. Any of you have any assignments already? No. Any of you have anything due yet? No. So why don't you work on the paper? Wait till the last week of class. You have finals coming up. You have last-minute tests. You have reports in other classes. Don't wait till then. Get it done early. Now, if you turn it in after that last day of class, you will lose points. Okay? But if you submit the paper early, like the month of, now this I have to update, the month of May, now there's not that many days left in May, but if you get it in the month of May, you get 3 bonus points. If you turn it in the month of June, you get 2 bonus points. If you turn it in the month of July, 1 bonus point. If you turn it in that last day of class, I think, which is in August, you don't get any bonus points. You just get your score. And if you turn it in after that last day of class, you start losing points. So please try to get there to me sooner rather than later. And by the way, not counting bonus points, this is just raw paper scores. Usually, now I've been doing this I've been here for about 20 years. I started doing the papers maybe 15 years ago. And I've taught, so 15 years. Back then we were on quarter system, 4 quarters a year. Now, more recently, we've been on semesters, 3 semesters a year. And I've taught anywhere from probably 3 to 8 courses a term. And most of the classes are bigger than this. I'd say averaging about 15 or 18 students in a class. I've had some really big classes and some not so big. So think of how many papers that is. And here's the general trend. This is a gross generalization. Usually the earliest papers I get in are some of my best. And usually some of the latest papers I get in are some of my worst. Because they waited till the last minute. Oh, I got this paper here. I got to get it done today. No spell check, no grammar check, no proofreading. It stinks, okay? Now, I've had some real dogs early in the term, and I've had some great papers late in the term, but the general trend is the other way. So please get it in earlier rather than later. Now, here's one more thing I require that I don't think anyone else does, or very few people. I've never heard of them doing it. When you submit your paper, I also want a single page from one of your sources. So say you have 3 or 4 sources. Pick one. I don't care which one. And then pick a single page from one of those sources and submit that. Okay. Now, if you do your computer application or whatever, then just send the link from that. You don't have to do a page from that. That's going to be hard to do. Just send me the link. Okay. Any questions on the paper? I'll get the things updated here that need to be updated, like months and bonus points and stuff. But any questions? Okay, sorry, this is going so. I'm through with that now. Okay, let's do this. Now, this is not current. This is summer 2016, last summer's locator card, but I'll get changed and updated to this summer. This is what it'll look like, and this is what it means. Every day of the week, try to be in the office by 7:45. Most days I'll be a little earlier than that. That's the time I shoot for, to be here before 7:45. Now, sometimes I hit bad traffic. I'm a little late, but that's very, very rare. Okay, I'm in the office for 15 minutes, at least. Sometimes it's 30 before class begins. But all 4 days a week I have classes now. Back last summer, I didn't have a class 8 o'clock Monday. In fact, all across the board, I had office hours then. But this time, my Cal 1 class didn't make, so I have that from 8 to 10:40. Okay? So that will go to here. Okay? Monday and Wednesday. Okay? Then my Cal 2 class did make, I'll say this here, 11 to 1:40. Okay? And now, right now, remember those 2 20-minute breaks? I'll try to have lunch, my first part of lunch. Boy, that didn't go back up, did it? First part of lunch here at 10:45 until 11. So I'll have 20, it's actually 20 minutes there, but actually in the office is going to be about more like 15. And then my second half of lunch will be same as here from 1:45 to 2. Now this summer is Physics 201 that's here. Last summer it was 201 was down here. That's when we had it late at night. So the Physics 201 class goes from 2 until 3:50, and then the lab was at 4 o'clock. And last summer we had 1 hour labs 2 days a week, but we did it whenever it fit best. But this year they said we had to have 1.5 hours. Okay, so that's why things are a little bit later. And then Physics 202 starts at 5:30, not 5 o'clock, because of that extra half hour. So at 5:30 it starts until 6:20, and then set 6:30, 5:30 to 7:20, and then from 7:30 to 9, or something like that. We may move up 10 minutes if you want to do that. Okay, let's go to Tuesday and Thursday. Last summer, like 8 o'clock class didn't make, but this summer it did. It really didn't make, but I have to teach it because one student needs to graduate. So it's a very small class, just like this one, but even smaller. But my 237 didn't make this time, so this is my block of office hours now. So I have class here, office hours here. Then here's the difference though. My lunch is going to have to be 11 to 12 because this summer my physical science class did make. It's not a big class, but it did make with 9 students. So that's going to be from 12 until 1:50, and then lab from 2 to 3:30. So I'll be sometime after 3:30. I will be off campus after that, and probably about the same time there. I've got to see how this matches up, because right now I've got something like 14.5-hour days on Mondays and Wednesdays, 13.5, something like that. And so my Tuesdays and Thursdays got to be a lot shorter. but I'm going to be here till 3:30. Going to be here at 7:45, so I'll probably be here until shortly after 3:30 each day. Okay. Now, folks, there's one more thing I've got to do before we get into physics. Sorry it's taking so long. I'm running out of energy too, so I'm sort of babbling. We got to talk about safety. I mean, we always have to think about safety. Now, what kind of safety do you think we have to think about? Second?
Tornado.
Yes, weather safety. It can be tornadoes, it could be straight line winds, it could be severe thunderstorms. If there's a big weather emergency and we hear the siren go off, what do we do? What do we do? What's the general rule? Go down interior. So what do we do here? We leave the classroom. You do not want to be in a room with windows when there's a weather emergency. Some limb could get thrown into the window. A car could get thrown into the window. That's not likely on the second floor. But metal, anything could get thrown into the window. That could hit you. The glass could cut you. You don't want to be here. So where do we go? Go out of the door here. Take a left into the hallway here. Go down that half flight of stairs. At the bottom of that half flight of stairs, immediately take another well. Go down one more flight of stairs, and right then you're near the lowest part of the building. That's where you want to be. So you go inward, not outward. Do not leave the building. You're in a weather emergency. Worst thing you can do. Go into the building, and actually, you're right in front of one of the safest places you can be. You want walls close together, and you want corners. And right there, you have restrooms. This is the second floor. The first floor is set up just like that. The restroom is really a pretty place, good, safe place to be. Because you have corners, interior, close walls, it's pretty secure. It's just not probably the place you like to be for a couple hours on a given day, Especially if the power goes off and you don't have any lights in there either. There may be some objections there. Another good place, go right past the restroom. There's actually another couple of flights of steps, a couple of steps down. Right there underneath this corridor here, on the first floor, is the dean's office. Now, they're not over here very much, but the dean is Dr. Cherie Davis, the associate dean is Dr. Carl Pruitt, and sometimes in the summer, Dr. Calvin Griggs uses that office when he's over here with his summer enrichment students. He'll use that office too. So if anyone's down there in the office, again, at this time of night they probably won't be, but again, the walls are closed, lots of corners, not a bad place to be, very interior. Right next to that is a classroom, okay? Right below this one. It's actually a computer lab for a math class, math lab. And that one, because it's a big space, you don't want to be in the middle. If something did happen above, it would crash down. You don't want to be in the middle. Stay near a wall. Corners are better, but walls are okay. Not the middle of the room. Again, though, in all those spaces, if the lights go out, power goes off, you're in the dark. So if you go one more, okay, right past this classroom here, there is a glass door on the first floor that gets you into the library area. So if you go in there, the first door on the right there is a computer lab. So that's a good place, an okay place to be. It's smaller than a classroom, so the walls are a little closer together, so it's more strength, you have a lot of corners, or 4 corners. Right next door to that is another room in the library. It's a little bit bigger, but it's what I call the reference room. That's where this atlases and that kind of stuff is, things you use for information, but you don't use to check out. They're not that kind of book. That's an okay place, but the negative side of that is if things do start falling around, a bookcase could fall over you. But the odds of that happening are pretty slim. So again, walls and corners are not bad. But actually, I've skipped over. You don't want to go any further in the library or anywhere on the outside because there you have windows. You don't want to be on the exterior room. So those places. The one place I haven't mentioned, and it's a good place to be, is the hallway. The advantage of the hallway, the walls are close together, so you have more strength there. The Only disadvantage, you don't have any corners, so you have to just be against the wall, but you got good strength there. The other advantage of the hallway over all these other spaces is emergency lighting at both ends. So if the power does go off in your own interior space, you don't have any natural light, you will have the emergency light. Now, just looking at you guys, you all look pretty healthy and like you can make it downstairs with no problem. The people who aren't here, I don't know what their conditions are, but if some of them are on crutches or have some mobility issues or even in a wheelchair, the wheelchairs are pretty tough. And here's why. Only way a person can access this room from with a wheelchair is through a stairwell way over here, the opposite corner of the building from here. You can't get up and down those stairs, and there's no other stairwells you can use. This one over here has a wheelchair lift, but it's electrical. So by the time the student, if they left here, went down the hall, if they can make it to the lift before the power goes off, they're okay. I would be with them to make sure they get down there safe. If the power goes off before or while they're in transit, I'm going to be with them. I might need to recruit somebody to help me get that person safe. That would be a tough task, but we won't be good. But you might just go to the interior room here. The point of my saying that is I'm going to be the last person down to the place. I will make sure everybody's out and we get there safely. That means if you beat me down there, stay together. You will beat me down there, or they're going to be the last person. Stay together until I get down. When I go, I'm going to carry a roll book and a pencil and pen, and I'm going to call roll and make sure everybody made it down there that was here earlier. If I am missing anybody, that means someone has to go up and risk his or her life, maybe mine, or help, looking for you in a place where it could be dangerous. So please stay together, at least until I call roll. We get everything covered. Yeah.
Okay, I just have a question about the class schedule.
Okay.
Okay, so today, is it 5:30 to 9?
Yeah.
Okay, so is it like that every Monday? I'm just
Yeah.
asking. 5:30 to 9.
Yeah, unless we go for 8:50. Okay. If we skip a break, then we'll do that. Yeah. So that's, and most of the time it's going to be class and then lab. But today, basically, this is lab, and then we'll get to the class the last one.
So we'll do lab every day.
What's that?
We'll do lab every day.
If we can. Okay. If we've covered enough material. Now, I meant to get there earlier, and I'm glad you asked. If we haven't finished covering material, I don't want to give you a lab that's based on stuff we haven't covered in class yet. So if we do need to have an extra bit of time to get it covered, then we'll do a longer time. Like we allow an hour and a half for a lab, but some labs will take 2 hours. So if we don't have time to finish it today, we'll just go and cover new material, and then the next day have 2 hours in lab or something like that. So most days it'll be class lab. Here at the beginning it's not. And by the way, I'm glad you reminded me because I do need to call roll again. I was supposed to call roll. I'm in the wrong class. I was supposed to call roll again at 7:30, and it's now.
7:35.
It's what? Yeah, 7:35. So it's right at the right time. Tia is still here. Megan is still here. Courtney is still here. Sam is still here. And Brianna is still here. Okay. Good deal. Do y'all need a break, or you want to just keep going and let me know? Huh? Keep going? You need a break? If we do, we can. Okay. All right. Okay, so there's the first safety issue, weather safety. What to do inside, lowest level, stay together until we're sure everybody's safe, and then we just wait it out. And then if you're going to go with friends or whatever, you can do that. but stay in safe areas. Let us know where you are. What's another form of safety we have to be aware of? Say again? Fire. That was whether from the danger from the outside coming in, so you stay in. If you got danger from the inside, you get out. Okay. But let's take it a first scenario. Let's say my computer blew up. Okay, and it happened to catch on fire my book here. What are we going to do? Say the fire initiated in this room, not by anybody's fault. It just happened. Okay. And that's a strange scenario, but I'll just make it up as if it happened. Hopefully it will never happen. What would we do? Okay, not run, but get out of here quickly is certainly something we will be doing. But we're going to do a couple of things before we do that. Maybe not everybody, but we've got to make sure we do it. If we just run, then the building's on fire and nobody else knows about it. Is that a good thing to do? Not. Say again? Ah, very good. We want to make sure if there's a fire in the building that everybody has a chance to know about it. So we want to do a fire alarm. Can anyone tell me where the closest fire alarm is?
I have to go to the left.
Okay, good guess. But not true. Okay. I think you're talking about the fire extinguisher.
Yeah.
Okay.
Because I'll be putting out the fire.
That's putting out the fire. That is a good thing. If the fire starts in here, somebody goes and gets the fire extinguisher. Good choice. So how about the fire alarm? We still need to do that.
Is it down?
Yeah. Here's the deal. All the hallway you see here, and every room off this old hallway, this is the old part of the building. This building's been here a long time. It was built before fire alarms were required by code. Strange but true. So you will not find a fire alarm anywhere on these hallways that are adjacent here. So what you have to do is go to a newer part of the building. Closest newer part of the building, go out the door here, take a left, go down that half flight of stairs, go up here to this thing called the corridor here, just past the restroom. That takes you across. It used to take you to the outside. This used to be a courtyard. They built this new wing in here, not really a wing, but this new area. By the way, that's first floor. That's why it's not showing up here. This is second floor, and this is first floor. Okay, that's why it's not showing. The strange thing is, this is also first floor, but they're showing this. I don't know why. Go across here, and immediately on going through the double doors here, you have a hallway going this way and this way, in either direction. It's a fire alarm really close. So go to the first one you see, the closest one. So I would say one or two people go down to make sure that alarm gets pulled. One person goes out here and gets the fire alarm, fire extinguisher. I will take care of operating it unless something's wrong with me, and then you have to operate it. Okay? There's something else we need to do. Probably, about simultaneous with that.
Call 911.
Absolutely, we need to call someone. Okay? Now, the best choice would be to have campus police on your speed dial and call them. They will notify 911, and they are closer. But if you don't have campus police on the speed dial, then you dial 911. They'll be hacked off at us, so we call 911 first, but you immediately call emergency right away. The alarm will also alert them. The 911 call needs to be, and get it the most. See that alarm going off, no one but us is going to know where the fire is. So you call 911, or preferably to the campus police, you tell them exactly where it is. In room 255, the upper point, blah, 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 whoever you talk to, this is where the fire is. We're trying to put it out, blah, blah, blah. You call them and tell them we're about to set the alarm, you'll hear it in a minute, that's where the fire is. Okay? So, we've done that. We've notified as many people as possible. We've done what we can to get out. The rest is what we do anytime we hear the alarm. And what's that? It's not run. It's get out of here. No, that's a different one. Okay. That's if you're on fire. Okay. Hopefully that's not happening if I'm being on fire. Okay. Now, in that case, you go out the door, take a left. Oh, by the way, did everybody hear where the fire extinguisher is? He said it, but y'all know where it is?
Down
Outside here. I mean, 5 feet, that's where I'm sitting, right here. There it is. You can't get much closer than that, okay? Now, how do you, anytime you hear the alarm, even if we said it, what do we do? Go out the door, take a left, down the hall, take another left, down the stairs, but this time rather than going in, you go out, okay? You leave the building, walking as far away from the building. Here's our room in this picture here. There's the stairwell we'll go down. And you go down to, it's hard to see at night, but there's a big parking lot right over here, okay? That's where we get. And we stay together in a group. And again, I'm going to be the last one out of here. I'm still trying to deal with the fire extinguisher or helping the last person out or whatever, and taking my roll book with me. And when we get down there, I'm calling roll. If you're not there, no one knows where you are. That means somebody, maybe me or some fire professional, has to come in and search the building, risking his or her life, and to rescue you when you may be off. Say, oh, no more class tonight, I'm out of here. No, don't do that. Stay together until we get word of what to do. Which is probably going to be to go home, but don't make that choice on your own. So that's what we do, and that would be fire, chemical spill in the building, anything such as that, that would be internal, we need to get out. There's one more safety issue that we have to be aware of. What's that? Bad news that we never used to mention, never even thought about it. Okay. Bombs, I don't know what to do about the active shooter. Same type of thing, terrorism, that type of thing. If there was that, okay, they are two different things. A bomb is a lot like a fire. You get out the same way you did before. Okay? Active shooter, though, is different from that. Okay? I hate that we even mention it, but it has happened on at least one community college, somewhere, Minnesota or somewhere else. Nowhere close around here, but it has happened. I don't even remember where, several years ago. And it's happened enough other places, like universities, what is it, Virginia Tech or somewhere like that has one, and some other colleges, universities have. Hopefully we don't or never will, but I don't know of any close to it. But what do we do? What are some of the things that we won't either happen or not happen if there's act? Oh, by the way, you're going here before me, I'm hard of hearing. If you hear something that sounds like gunfire, stop me right mid-stride and say, that sounds like gunfire. Okay? What do we do? Very nice. Okay. Okay. Here, she just said it because she was here last year and she remembered, right? We make sure this door is locked. I do that because I have a key that will lock this. The trouble is, you can't lock it any way except from outside. There's no keyhole here, but it is on the outside. I have to go out there, fix it so it will lock, come back in and close the door. Okay? Then it's locked from the outside, but we can still get out. Okay? And turn off the lights. But we're not going to do that quite yet, unless gunfire sounds really close, because there's another entrance to the room. Okay? Now that classroom over there, and this is just a little piece of information. For some reason, security, about half the time, or maybe more than half the time, doesn't unlock that door for that room that they do for this one. So, I don't have a key for that. Now, Dr. Bryant got here today. He had to come in through my classroom I was teaching to get into his office and to get into his classroom because the door was locked. Which, if there's active shooter, that would be a good thing for us. But if someone's opened the door, then what we have to do is go around and close that door, the one to the hallway. If it's locked, fantastic. If it's not locked, it's still better to have it closed and turn off that one. But then, would you lock this door? What do you think? Yes. Okay, here's the problem with it. It does have a button here. I press the button, it's locked. But it's locked from the outside, not from the inside. So you just lock us in, but he can come in from this way. So no, don't lock this door. Okay? We want to be able to get out if he shoots us out. This door has a and I don't have a key for that, so I can't lock that.
So
That door, yeah.
So basically that door's over there while we're in.
Now it locks from the outside, so they can't get in, but we can get out. So that's the one we lock. But before we do that, we go around and close that other door. In case it looks like
I know. We did.
I'll be back. Then we close this door like that. Because these two doors have glass, you can look in here and see if you can see it. Close this door, you can't see that we're here. Then we close that door and this door. That one's locked, that one's locked. We turn off the light and we all get back here. Because you can fire through wood, a lot harder to fire through concrete. Okay? In fact, I think you'll be more damage than we would if you tried to fire close right to the concrete wall. Because out there it's hot. Huh?
He could get in.
He can
Through
get
the
it.
wood, right?
Huh? The bullet could maybe come through the wood. It depends on how powerful.
But you'll be over here.
But if you're over here, you can't get through.
But he can shoot the lock off.
If he can, okay. But you see, if we turned off the light, turned off the projector, and we're very quiet in here, at this time of night, something brings in. Door's locked, security's already been here, it's gone. Okay. Don't worry about it. I don't think it's going to happen. But these are the things we need to think about ahead. We wait until we hear from someone, an official, that says the coast is clear. Okay. And also, I forgot to say this. While I'm doing this, you're calling 911 for sure. Campus police even better if you got it on speed dial. Say that. But if you don't have it on speed dial, 911 for sure. Get all the information out, and then we hide. And that way guarantees someone's going to come and ultimately notify us when this is good. Okay. I hate that we have to mention this, but it's better to be safe than sorry. Okay. All right, that's all I can think of for it. Now, you might think that our labs, since we will be doing a little bit with electricity, that you might have an issue. It's going to be very low voltage, very low amps. I can't think of any way you could ever, but always think safety on that as well. Now, there is one other. Remember the light and optics? There is one lab, I don't know if we'll get to it, but if we do get to it, we will be using a little laser pointer. Now, that sounds pretty safe, doesn't it? But if you shine a laser pointer into someone's eye, you can damage their retina, your own eye or somebody else's. Be very careful. You never point a laser pointer at somebody. Use it to point somewhere else, but never at somebody. Now, I'll mention that again if we do that lab. Okay. My word. I'm through with that. Any questions? Safety or my office hours, syllabus, research paper, anything? Any questions? Okay, if there are none, let's start in chapter 14. Now, again, I don't see anyone with a book, so I'll try to hit this using the slides and stuff like this. Now, again, this is the 9th edition slide, but I don't think much has changed. If I see anything that's changed, I'll let you know. Okay? And I think you'll see that there's not a lot of difference here. Sound waves. Okay? Couple things about sound waves. There are really more than two primary types of two major types of waves. One is called the longitudinal wave. That means the wave action is in the same direction as the wave propagation. For instance, sound is a longitudinal wave. If you put your hand in front of your face, your mouth when you're talking, you will feel little pulses of air hitting your hand. You probably can't hear me as well either because I'm blocking those sound waves. Sound waves, there's another name for it, and it's also called a pressure wave. That's longitudinal. The air is pressed together or separated, that's called pressurized or rarefied. That's what makes the wave, and it's in the same direction as the propagation of the wave. That's why we call them longitudinal waves. The other major type of wave is called the transverse wave. I don't know if you did this as a kid. I remember doing it, and I loved doing it. I don't know why. It just was a fun thing to do. It may be a Y chromosome fault or something like that. But if there was a hose on the ground, a garden hose and stuff like that, I like to take the hose and do this to it. And what would happen? That wave would go wiggling down the hose, wouldn't it? If you've never done it, go home and do it sometime. The hose is out there. Pick it up and yank it down. Well, now think about what's happening there. Your motion is this way, but the wave propagates that way. That's a transverse wave. Sound waves are not transverse waves, they're longitudinal waves. Okay? That means the motion is in the same direction as the propagation. Now, the characteristics of sound waves will help you understand how we hear. So that's what we're talking about here. .1, this is topic 14. They don't call them chapters anymore. Topic 14. 14.1 is producing a sound wave, which is the title of this slide. Okay? Any sound wave has its source in a vibrating object. Wait a minute, am I making a sound? Yeah. What's vibrating? My vocal cords. Exactly. And then it's being projected out my mouth. And, okay? I don't know how the ventriloquists do it, but anyway, yeah, they're still making the sound, but they're not moving the lips much. Okay? So any sound wave has as its source a vibrating object. How about a drum? Yeah, the drum skin is vibrating. If you looked at it real closely, it would be doing that. Cymbals, the same thing. A trumpet. Okay? What's vibrating there? You're vibrating with your lips. Now, a clarinet, a reed instrument, you don't realize it, but there's a little vibration between the reeds. I don't know enough about the piano. That makes a sound. Every time you hit a key, a hammer hits the wire and the wire vibrates. You don't see it, but it's happening. So all sound waves has as its source a vibrating object. Sound waves are longitudinal waves traveling through a medium. Now, when we say through a medium, what would that include? A medium. There are three phases of matter. What are they? Solids, liquids, and gases. Those would be the mediums. Does the sound wave go through all of them? Yeah, it'll go through solids. You remember the old cowboy and Indian movies? If the Indians wanted to know when their train was, or the cops and robber movies too, if the crooks wanted to know when the train was coming, what would they do? Put the ear on the track. You're going to hear it through the metal far sooner than you'll hear it through the air. Okay? If you've ever been in a swimming pool, you can hear things going on underwater actually louder than if you were above water. Okay, you can't hear what's above, but underneath. Okay, and certainly in air, sound is moving. So it has to go through a medium. So what if we were in a vacuum? No sound is transmitted. There's nothing to transmit it. There has to be a medium. There has to be a vibration at the source, and there has to be a medium to carry that vibration. And it can be solids, liquids, or gases. Okay? A tuning fork is a classic thing of something that makes a sound, right? Those tines on the tuning fork are vibrating. And it can be used as an example of producing a sound wave. And here's the illustration. Now, this was 2 editions ago. This is exactly figure 14.1a, right there. You've got it. When you hit a tuning fork and it goes, ding. You've heard that, right? What's happening, this thing is vibrating. It's compressing the air around here, and then when it vibrates the other way, you call that rarefaction, okay? Compression, rarefaction, compression, rarefaction. There it's rarefied, compressed. This is on the way back here, so it's rarefied again. This is your high density region where it's been compressed. A tuning fork will produce a pure musical note. That's how they make them. So each tuning fork, different size, is going to produce exactly that one musical note. Now, any of you have bell choirs at your church? Those basically have something sort of similar, but not quite. They're trying to hit one particular note. As the tines vibrate, they disturb the air around them, like I was talking about. As the tine swings to the right, it forces the air molecules closer together. As it pulls back to the left, and that produces a high density area, and that's called an area of compression, and that's why the other name for a sound wave is a pressure wave, because it produces pressures, rarefaction, pressures, and rarefaction. So that's the high density region, also the area of compression. When they pull the other way, this way, then you form the rarefaction. That was a rarefaction, this is a rarefaction starting to happen. Okay? Now, so the motion is back and forth like this of the vibration, and the wave is going that way. If this one's actually doing too, it's coming this way. So it's going in both directions there. As the time moves to the left, that forms an area of low density. Okay? And that's called rarefaction. The rarefaction. The time moves to the left, the air molecules to the right. The air molecules to the right of the time spread out because it's pulling back this way, and that's your low density region, which is the area of rarefaction. And that's exactly figure 14.1b in your text. So you see, 2 editions ago, they're still using the same slides. I think we'll be safe with this. There may be some places we don't have it, but I think most of the time we will. The new editions are mostly just to make the company more money. So far, the only thing I've noticed, they've changed from calling them chapters to topics. Big change. Okay? 14.2, this is exactly it. And this is A and B down here. As the tuning fork continues to vibrate, a succession of compressions, rarefaction, compression, rarefactions, they spread out away from the fork. And if you wanted to represent this with a sinusoidal curve, you've had trig, you know what that means. When the tuning fork is in its original position, not to the right and not to the left, you have no compression. The air is normal. As it presses this way, you have a maximum. Then you come back to the normal. As it goes back this way, as it comes here, you have a minimum, because that's your rarefaction. Then the density starts increasing again until it reaches normal and goes back to maximum. And then, so this is what produces how we can represent a sound wave as a sine wave. Okay, sound and sine. The sinusoidal curve can be used to represent that longitudinal wave. The crest corresponds to the compressions, the troughs to the rarefactions. And the points in between is where the time would have been back at its original position, so you neither have compression nor rarefaction. That would be the normal situation. 0 compression or rarefaction. Does that make sense? Okay. Now, what are some of the categories of sound waves? If you got your books or later are reading at home, we've just turned the page to 14.2 is characteristics of sound waves, but 14.2.1 is categories of sound waves, and that's what this slide is. What are some types? Well, you have audible waves. Now, what makes a sound wave audible? It's the receiver, if you can hear it. If these waves lay within the normal range, I don't like the word lay, but I guess it's okay. within the normal range of hearing of the receiving, which is your ear. Now, is your ear the same as your dog's ear? No, it is more quiet. No. Okay. No, because dogs hear a different frequency from ours. That's why a dog whistle, you can blow it, you don't hear anything, but the dog does hear it. Sometimes it's very irritating to them. Okay? Is your range the same as a bat's range? No. Because bats they're almost blind as a bat. They do all their navigation, flying and everything by hearing. They send out little signals and when they hear an echo back, they know they're close to something and they change course. They can detect bugs, mosquitoes, as tiny as they are, by sending out their thing. They're blind, close to being blind, they go by sound. And we don't hear them. Now sometimes, I guess if you're around bats, you might hear them. Very faintly. Now, how about your hearing and my hearing? Obviously not the same range. I'm old. Now, you remember when cell phones first came out? You maybe were too young for that. Okay? You remember that? And people got all these different rings. Okay, you don't. Okay, I'll tell you. It's history. Old, ancient history, but I'll tell you about it. When they first came out and kids in school had the ringtones, they chose the ringtones and stuff. Some kid found out, I think this was in Britain, that young people typically have a far wider range of hearing than certainly older people. So kids at school would hear frequencies that the teachers could not hear. So they set all their cell phones to be a frequency they could hear and the teacher couldn't. And then they could call each other or send things, and the teacher would never know. Until they happened to have one young teacher whose hearing was way better than what most were. She heard them, she figured out what they were doing, and then they figured out a way to stop it. So those kids had a field day for a few days until she found it. Normally, and these are, you know what the HZ is? Hertz, okay? And by the way, there's a person's name. Anytime you see a unit that's capitalized, that's part of the unit, that means it's named after somebody. So Heinrich Hertz would be a potential paper topic. Right there is one, okay? The human ear, audible ranges changing as you age, difference between dogs and bats and people, that any of those are possible paper topics, by the way. And we've only had, 3 slides? So the normal hearing for our human ear is between 20 hertz and 20,000 hertz. Now, one thing about this book, it's very European in a sense. In the metric system, they typically don't put commas between big numbers. They leave spaces. So I would write that 20,000. In this book, because this is SI, they leave a space between it. So if you see that, it's not that someone has a typo error, they forgot to put in a comma or left a space where they shouldn't. That indicates what a comma is for us. Okay. Now, so those are the audible rays. You have some above and below the audible region. The infrasonic rays are frequencies below the audible range. That would be less than 20 hertz. Okay? Earthquakes, believe it or not, sometimes you won't hear an earthquake, but possibly animals might if they have this infrasonic range that we don't have. And sometimes they can get real panicky, and we don't know why. And frankly, I wonder if tornadoes sometimes don't produce a low frequency sound we don't hear. The reason I say that, I grew up on a farm in Georgia, and I wasn't there when this happened, but it hasn't been that long ago, probably a decade or so ago. A very low range, Category 0 tornado went across our farm, okay, in Georgia. But even though it was a Category 0, it wiped out a band of trees, really thick trees, and you can see right today where the path was, because trees on either side, not trees here, okay? Now they cleaned it up, and it makes it more stark, but the trees they had to cut down because they were all twisted and stuff. And this was the lowest range of tornado they had. Well, the reason I brought this up, this is so bizarre. My younger brother was living, in fact, all my siblings still live on the farm. I'm the only black sheep that came over here to Alabama. They're still back in Georgia on the farm, okay? But my younger brother's older daughter, who had been dating this guy, and they were engaged to be married. So my brother wanted to invite his family to the farm so they could see her. Get this, my brother's children have all done very well in marriage. This daughter was dating and now is married to the son of the head chief of pediatrics at the University of Ohio State University Hospital. That would be like the chief of pediatrics at UAB Children's Hospital. Okay, pretty high-ranking guy. And here, my brother was inviting him to the farm to see where we live, and my brother's in a little modest 3-bedroom, very small, house on the farm, a ranch house on the farm. It's adequate, it's fine. We have old trucks and tractors and things like this. It's not very impressive, but the people are very gracious and they had a good time. But Dan decided he wanted to show them the farm. They had just gotten there, and it looked like there's a storm coming. So he wanted to show them the farm before the storm came and the rain started falling. So he had driven them out to the field to see the herd cattle, and he was talking about this, that, and the other thing. And suddenly it got so quiet and such sort of eerie feeling. And they looked around, the cows had disappeared. They had been out there with the herd really close to them, not super close, but so they could see them and stuff. Suddenly there was not a cow in sight. What? And everybody felt something strange. They looked across the field, it was our neighbor's field, and they saw the tornado ripping across the field in sight of them. Now, it wasn't a huge one, but it was doing. So here, Dan hustled this big doctor, head of pediatrics from Ohio State University Hospital, his wife, his son, his daughter, Dan's daughter, into the field, into a ditch, and got as low as they could go. If you're out in the open, you find the lowest area you can get to. And they were huddled down on the ground in the ditch. I'm surprised he didn't say, son, let's get out of this place and away from these people. But he didn't. They're married. They've just had their third child, and they're happily married, living in Raleigh, North Carolina, not on the farm. Okay. But we all wondered how in the world the cows knew the tornado was coming and the people didn't. And I wonder if it didn't make them. If earthquakes can make an infrasonic sound wave, why can't a tornado? Until it gets closer, you can hear them when they're close, but at a distance, it probably made a sound we can't hear. I'm guessing the cows could. That's just a guess. I don't know that for a fact. And then on the other end, the ultrasonic sound wave. Those are frequencies above the audible sound range, which would be above 20,000 hertz. Dog whistles are that example. So dogs can hear the high frequency. Now, it may be the tornadoes make high frequency and the cows can hear like dogs. I don't know. Don't know which side it is, but something alerted the cows to the fact the current tornado was coming way before the people knew. Now, it could also be they're more sensitive to pressure. I don't know. But my guess is it's probably more likely sound. So ultrasonic waves, you're blowing it. You might say it's not making a sound. Yes, it is. You just can't hear the sound. Okay? So that's the categories. Applications of the high frequency ultrasound. We've already mentioned dog whistles, but these can be used to produce images of very small objects. Okay? Okay? And where do you know of ultrasonic waves? You just heard his alarm bell. No, okay. Anyone ever heard of ultrasonic waves? Or an application of this? I don't want to ask it of you, but have you ever known anyone who is pregnant? Guess what they do? They go and get an ultrasound. Okay? Now, I've never been pregnant, but I've had an ultrasound. Okay? I don't want to get too gross with this, but I had a doctor. He's a young doctor. There's a mistake there, I think. He was a sort of a nervous kind of guy, or else he was just trying to build for his practice lots of procedures. I don't know which, but he had me go through every time I had a physical. I mean, he did everything, and maybe it's good that he did, but he had a urine sample. I don't mean this to be gross or anything. I sure didn't see anything wrong with it. This seemed pretty good to me. But he said there was microscopic blood in my urine. It hadn't discolored itself. He said it was very microscopic. So therefore, I could have bladder cancer. Now maybe he was really serious, or maybe he was just a panicky kind of guy. So he had me go and have an ultrasound. Now, I didn't have anything wrong with my bladder at all. But it was so fortunate, so I think there was more to it than this, that the technician decided to just keep going around. And then she said she saw what was a shadow near my right kidney. And she didn't know what it was. She said it could be gas or something like that. But it was something she saw that was out of the ordinary. She was used to doing it. So she called in her supervisor, and he looked and said, it really looks like there's something there. So they sent me to have an MRI. So I went to have an MRI. I went to have the MRI, and sure enough, there was I'm trying to remember the order of this. At some point, we got away from that doctor and went to see a specialist, a urologist. And I think he's the one that had me do the MRI. But he said, here's what I'm guessing. And he saw the pictures and stuff that they had taken of the ultrasound. And when they did the MRI, they found out I had what we call an angiomyolipoma. It sounds pretty dangerous, but it isn't. Angio is blood, myo is muscle, and lipoma is fatty tissue. It was just a thing that had it. But I had a ton of them near my kidney. There's a bunch of them in there, except one was sort of big. That's what they were seeing. It was about 4 centimeters, so it's a pretty good size. And the other thing is, if it was growing, then it could rupture, and because of all that blood, their kidney, they wouldn't be able to operate in time to keep me from bleeding out internally. So they said, we need to remove it. So ultimately, that's the story. And later, I went back after the operation and everything else to see the urologist and have routine visits. And it happened to be sometime after all the surgery and everything else. I said, oh, by the way, the reason all this got started is this doctor I used to have by this time I left him. And I said, he was concerned about I'm trying to think. Yeah, the blood and the urine in it, because it was so small, it was microhematuria or something like that. It had the hema for blood and the urea for urine, in the urine. And he said, oh yeah, but that's nothing to worry about. So if I had seen the urologist, he would have dismissed that with no problem, and they never would have done the ultrasound. But because this guy was panicky, they did do the ultrasound, then they saw the thing, and who knows, it could have saved my life. Who knows? an unusual thing. My father's sister, just above him, he was the baby in the family, the sister just above him, she died of something that they didn't know if it was aneurysm or something. Something ruptured inside of her. She wasn't in ill health or anything, and she died before they could get her to the operating table. And I wondered ever since if she let have the same thing I did, a angiomyolipoma that doesn't do anything but may have ruptured. So I don't know. It just was interesting. But so I've had an ultrasound. They can be used to produce images of very small objects. Widely used as a diagnostic treatment tool in medicine, the ultrasonic flow meter is used to measure blood flow. So you can actually, I've seen pictures of this, it hasn't been me, you can see the blood moving through the veins and arteries, okay? Because it can pick up that very small thing. I think it's mostly the red cells. May use piezoelectric devices that transform the electrical energy into mechanical energy, okay? And it's also reversible, that changes mechanical to electrical. So that's what they're doing. So the ultrasounds are used to observe babies in the womb, and if they get the right angle, they can detect enough body parts to determine sometimes the gender of the child, you know, while it's still very, very small, okay? The Cavitron ultrasonic surgical aspirator, CUSA, it's not Conference USA, but something else, used to surgically remove brain tumors, only using sound. Ultrasounds that actually break the tumors apart. Wow. High intensity focused ultrasound, HI, high intensity focused ultrasound, HIFU, is also used for brain surgery. Okay? You certainly want to use something like that if you can avoid actually cutting into the brain. There's all sorts of things, infections and stuff you don't want happening there. Ultrasound can avoid that. Ultrasonic ranging is used in cameras. Okay? Ultrasonic ranging, I think that's what bats use. Like they said, produce images of very small objects. The bats are all set up to sense that. Even as small as a mosquito moving, the bat goes in, zooms in on it, eats the mosquito. That, by the way, is the only advantage of bats. They eat mosquitoes, okay? Otherwise, I think they're pretty gross animals, okay? All right. Now, speed of sound in a liquid. They say liquid up here, but down here they say fluid. Does anyone know the difference between a liquid and a fluid? You aren't expected to. I just wondered if you knew. Fluids are either liquids or gases. That's fluid flow. The air coming out of the ventilation duct is fluid flow, just like water coming out of a pipe is fluid flow. Liquid is liquid, gas is gas, but a fluid can be either a liquid or a gas. So in a fluid, that can be either a liquid or a gas, the speed depends on the fluid's compressibility and inertia. Okay. Now, y'all have all had Physics 1. You remember what inertia is? You two had better say yes. No, never mind. I'm kidding. What is inertia? What's the first 5 letters? Inert. What does that sort of communicate to you? Not doing anything, right? Inert. Okay? Not inert. No, I'm sorry. Okay. Inert. And basically, now, inertia isn't just not doing something, but inertia is the tendency of an object not to change its state of motion. Remember, Newton's first law was the law of inertia. Please remember that. Okay? So that depends on the mass of an object. Okay? So in a fluid, the speed depends on the fluid's compressibility and its inertia. So speed is velocity. Okay? It's equal to the square root of, so it's not a direct dependency, it's a square root dependency. And the B here is the bulk modulus of the liquid. That has to do with compressibility. Okay? Rho is the density of the liquid. Density is mass per unit volume. Mass is related to inertia. Okay? So that's how they do it. The more compressible the fluid, the greater the velocity. The more massive the fluid, the smaller the velocity. The less compressible the fluid, the smaller the velocity. The less massive, the greater the velocity. It's an inverse relationship with the square root of the density and a direct relationship with the square root of the bulk density, bulk modulus. Okay. Now, this compares with the equation for the transverse wave on a string. The trouble is, now this is Alabama as opposed to the author of the book. I just finished teaching 201, okay, earlier today. 201 does vibrations and waves. 202 does sound, okay? Those should be together because this is talking about waves, okay? And now notice the difference there. This compares with the equation of a transverse wave on a string, how that's related to the velocity of a compressional wave or a longitudinal wave in a fluid. So you see they are very similar to each other. And guess what? The sine wave, that looks like a transverse wave, but it can be used to relate to a longitudinal wave as well. So you see there's a lot of similarities there. Okay. So the other way to look at this, I just said it, velocity of a wave is the square root of the elastic property, which is the bulk modulus, divided by the inertial property, which was the density. So the speed of sound is higher in solids than in gases. That's why the crooks or the Indians, whoever happened to be listening to the rails in the Western movies, they could hear the sound far sooner because the speed of sound was higher in the solids than it would be in the gases. The molecules in the solid interact more strongly, more directly related to each other. Gases, the molecules are further apart and they dissipate much more quickly. The speed is slower, and that's the elastic property. The speed is slower in liquids than in solids because liquids are more compressible. And the bulk modulus is the inverse of the compressibility. So liquids are more compressible. The bulk modulus is lower than a liquid. Well, there's several things going on there, but the bulk modulus would be the resistance to that. Okay. The speed depends on, okay. The next is speed in the solid rod. Okay? And by the way, let me back up a slide or two. The speed of sound, starting on this slide that we already did, that starts 14.3 in the book. Okay? And then we had speed of sound in the liquid was right at the bottom of page 459. I'm trying to give you references when you do get your book. This is at the top of 460 is this equation, and they're talking about that. And then this next equation is near the middle of 460. The speed depends, okay, another example of this general form is the speed of a longitudinal wave in a solid rod. This would be more like the railroad track, the rails of a train. The speed on the rod's compressibility, and by the way, you have several moduli, and this was done earlier in the book, and that's why they're not explaining them here. So once you get your book, you'll have to look at this. Young's modulus refers to linear compressibility. Bulk modulus compares to volume compressibility. So this is Young's modulus, and you see it's almost directly like the other one. The other was the bulk modulus, which is B. Young's modulus is Y. And rho is, again, the density of the material. So again, very, very similar form. Okay? Elasticity, the square root of elasticity factor over the inertial factor. Now, this equation is 14.4 in your text, near the bottom of page 460, and that's the speed of sound in air. Okay? Now, in air, there's another feature that you have to take into play. We talked before about liquid. There you use the bulk modulus because you talk about the whole volume. And a rod, a solid rod, you talk about Young's modulus because you're doing linear. In air, again, it's sort of a bulk modulus type thing, but we're not dealing with that here. What we're dealing with this here is this is the speed of sound at the freezing point, at 0 degrees Celsius. Okay? That's the freezing point of water, not of air. Freezing point of water. Now there, air is fairly dense. Okay? Now the denser fluid is, the faster the speed will be. Remember? No, sorry, backwards from that. The slower it will be because your inertial property is in the denominator. So as you raise the temperature, the density expands and the speed goes faster. Okay? And sure enough, when you raise the temperature over 273K, 273K is 0 degrees Celsius. Remember? This is absolute, or Kelvin scale. This is Celsius scale. 0 degrees Celsius is 273K. So if you're at a higher temperature, the square root of that, if you're at a higher temperature Kelvin than 273, then this is going to be a number greater than 1. The square root of that is going to be greater than 1. So then you're increasing the velocity. If your temperature is below 0, colder, then this is a smaller fraction. The square root is a smaller fraction. It's less than 1. That decreases the speed of sound. And that's again related to the inertial property, the density. Density is greater at lower temperatures, less at higher temperatures, so that still fits. With T is the absolute temperature. Okay? So if that temperature is higher, then your speed goes up. If the temperature is less than 273, below 0 Celsius, then your speed goes down. Now, you see why you have to use the Celsius scale? I mean the absolute scale or Kelvin scale? If you try to use 0, you can't put 0 in the denominator. That's one reason. A negative temperature here would give you a negative speed. No, that doesn't make any sense, okay? So you have to do the absolute temperature where this never goes negative. That's why it's called absolute. It never goes negative, and then this will give us the right direction. Never going negative. It slows it down, but it doesn't go negative. All right, next okay. Before we go to intensity, which is 14.4, let's look. There is a quick quiz. Can I count on y'all keeping up the time for me? Okay, y'all are good to do that. Either 8:50 or 9. But let me know when we get close. Okay. There is a little quick quiz in the book. I think these are worthwhile to do. Which of the following actions will increase the speed of sound in air? Based on what we've just talked about. Okay? Decreasing the air temperature, increasing the frequency of the sound, increasing the air temperature, increasing the amplitude of the sound wave, or reducing the pressure of the air. Which of those is going to increase the speed of sound in air? Okay? Obviously, temperature will do it. Okay? Because this is a formula for it. Temperature affects density. Density is an inertial quantity, so that affects the speed of sound in air. The only other thing is the compressibility. And guess what? Frequency has nothing to do with either compressibility or density, so that won't change the speed of sound in air. The amplitude of the sound wave, that just is loudness. It doesn't change the speed. And the pressure. Pressure doesn't change either inertial property or goodness, it's late at night, I'm going on. Or compressibility factor. Okay, it doesn't change either one of those. Okay, so it's got to be temperature. Which one increases the speed of sound in the air? Increasing the air temperature or decreasing the air temperature? Decreasing is A, increasing is C. What you reckon? Which will increase the speed? Increasing. You make this a larger number, this goes up more. Make it a smaller number, it goes up. Okay? That's a direct relationship. Okay? Now, where do we find the answer to the quick quizzes? I think it's the end of the chapter, but let's see. Goodness gracious, where is this? This is a long chapter. Wow! It may be in the back of the book. Let me see. I've got to find this somewhere here. Nope, it's not the end of the chapter. It must be in the back of the book. Yeah, now that I think about it. This is topic, remind me, 14? Yeah. Yeah. Topic 14, number 1, 14.1, C, increasing the air temperature. Okay, I really need to put a marker back here. I think I'll put this. Okay. That may have taken too long. Applying Physics 14.1, sounds heard during a storm. How does lightning produce thunder, and what are the causes of extended rumble? Okay. It really is a good read. I don't want to get into it too deeply here in class. When you get your books, read that. I mean, it's really good stuff. Let's just move on. There are some things that really seem like it's worth taking the time to do, but I don't think we have time to do it. There's another example, 14.1, and they don't do this one. This is actually a problem, and I wish they had more of these on the slide set, okay? We're just going to have to see how it goes in here. I'd like to do more of these problems, but they're going to take a fairly long amount of time. So again, once you get your book, these are really worth your time to read through and do. And they really do a pretty good job of explaining them. So let's move on to energy and the intensity of sound. Okay? So let's look at some of the measures we talked about. We've already talked about frequencies and what we can hear and what we can't hear. That was frequency. Now we're talking about amplitude. No one could hear that, could you? Could you? What did I say? Even though I was talking at a frequency you could hear, in other words, no amplitude you could hear. So that's what we're talking about here, the threshold of hearing. That's what we're talking about, intensities of sound. If I yell real loud at the same frequency I'm talking now, you can hear me better, but it's the same frequency. It's not a frequency matter, it's the intensity matter. Okay? If the intensity is too low, you can't hear it. So the threshold of hearing talks about intensity, not frequency. Before we were talking about frequency. The faintest sound that most humans can hear, and there's a weird unit here, is about 10 to the minus 12. Does anyone remember or know what a W stands for? What unit that is? Watt. What? Okay, never mind. Okay. That's a watt per meter squared. Watt is a measure of energy, so that's an intensity. Okay? Watt per meter squared, about 10 to the minus 12 watts per meter squared. Now, when I was talking real softly, you could hear me, but she couldn't. Now, why is that? What I just said was when I was talking real softly, she could hear me, but she couldn't. Why? Because the intensity falls off as the distance squared. Okay? And since you're closer to me, you could hear me whisper, maybe she couldn't. Okay? Because by the time it got to her, it was so dispersed, it was not intense enough for her to hear. I can even hear my whisper because I'm real close. Okay? Most of the time I can. The threshold of pain is then this is the lower limit. The threshold of pain is sort of like the upper limit. The loudest sound that most humans can tolerate, they can hear louder, but they just can't tolerate them, is about 1 watt per meter squared. So look at that range, folks. If you thought the frequency range was impressive, which I thought it was, 20 to 20,000, that's a ratio of 1 to 1,000. Okay? That's a 3 orders of magnitude range. Wow! Okay? But look what it is in intensity. The range is, did I go too far? No. Oh, I must have skipped this slide before. How did that happen? Sorry about that. Let's back up and hit this slide. I was wondering why they jumped to this and didn't describe it to you. Sorry about this. The average intensity of a sound wave, and that's called I, the average intensity I of a wave on a given surface is defined as the rate at which the energy flows through the surface, or delta E, or delta T. Boy, I wish they'd written that together. The ratio of the change of energy over change of time. That the rate means time rate of energy change. Okay? Now, do you remember what the units for energy are? Joule, exactly. And a joule per second is a watt. A watt. Okay, yeah, that's a watt. So there's where the watts come from. That's the rate of energy flow. Rate of energy flow is power. Power is measured in watt. Divided by the surface area A. So this is where they got that. Intensity is power per unit area, which is the change of energy per change of time per area. Okay? So the direction of the energy flow is always perpendicular to the surface at every point. Okay? Energy goes through a surface perpendicularly. And the rate of energy is the transfer of power, and the unit is power per unit. Okay, SI unit, watt per meter squared. Okay, and that's where that unit came from. I guess when I hit the button, it went 2 rather than 1. So here is the range of power or intensities that we hear. From 1 times 10 to the minus 12 to 1. That is where the other was 3 powers of 10. We call that 3 orders of magnitude. This is 12 orders of magnitude. Wow, what a range we have. Frequency, a pretty good range, but pretty small compared to the range of intensity. The ear is a very sensitive detector of sound waves. It can detect pressure fluctuations as small as about 3 parts in 10 to the 10th. That would be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's 10 billion. Okay, I want to make sure I said it right. That's 1 plus 3, 3, 3. So 3 would be 1,000 million billion. That would be 1 in 10 billion. Wow. The sensation of loudness is logarithmic in the human ear. What in the world do we mean by that? Do you know what we mean by a log scale? Logarithmic? Okay. How are you in math? Pretty good? Okay. What was the inverse function for a log? Say again? E? Is that what you said? Yeah, exponential function. Okay? Now, when they're talking here logarithmic scale, they're basically talking base 10 log. You're thinking natural base, E. So that would be raising 10 to a power is the inverse of a log base 10 scale. Okay. Now, beta, y'all recognize that Greek letter? Beta is the intensity level or the decibel level of the sound. Okay? So this is the decibel level. I think of beta because bell is in there. Okay? Decibel would be, deci usually mean 1 decimal place, and I think that's where the 10 comes into play, times the natural log. Now, it could be either log, but usually it's not the natural log, but the base 10 log of the intensity divided by the I0. Now, what is the I0? It's the threshold for hearing. That was this thing right here, about 10 to the minus 12 watts per meter. Threshold for hearing. That's the lightest sound that you could hear. Okay? So that's your scale. Okay? Now, what happens when you double the intensity? Not much difference. But if you multiply this by 10, then, so if this intensity was 10 times this one, 10 times I0, the I0 value, the base 10 log of 10 would be 1, and that would be 10, a decibel level of 10. Okay? If I were exactly your I0, the threshold, then this would be 1, log of 1 is 0. Yeah. So your decibel level would be 0. You can't hear anything less than I0. That's the threshold level. If this was 100 times I0, then the 100 times I0, the I0s go out, log of 100, base 10 log of 100 is 2, 2 times 10 is 20. So you would go from before it was 10, now it's 20, okay? So that's how the decimal levels go. You multiply this by 10, you raise this by number 10. Okay? Raise that, multiply it by 100, you increase that by twice that amount. That goes to 20. That's 1,000, it goes to 30. So you see, that's what a log scale does. It takes a big number and makes a more reasonable scale of it. That's what a log scale does. So I0 is that threshold for hearing. Is this making sense? Y'all remember logs well enough that way? Okay. So let's look at the intensity versus intensity level. It almost sounds like it's the same thing. Not quite. Intensity is a physical quantity. How intense is something? An intensity level is a convenient mathematical transformation of intensity to a logarithmic scale. So intensity would be how many watts per square meter you have. Intensity level would be on the log scale, that's your decibel level. This is going to be a wide range there, 10 to the 12th, remember? This is going to be a much smaller scale, basically 0 to 120. 10 to the 12th, 0 to 120. That's a big difference there. And that's how intensity levels measured in decibels, much smaller, more reasonable numbers than the intensities, which can be huge, very, very large. Yeah. Oh man, it's getting close. I have just a couple minutes. Let's do this slide. Let's see where we are here in this. Okay. The threshold of hearing, like I just said by the formula, is 0 decibels. That's what determines 0 decibels. Threshold for hearing. This is in intensity. The threshold for pain, remember I said that was 10 to the 12th, so that's 120 decibels. Please, folks, don't expose yourself to really anything close to that. You can damage your eardrums pretty badly, perhaps irreversibly. So folks who went to rock concerts their whole lives and sat real near those woofer speakers, some of them are deaf today. Now, I'm deaf, but it probably isn't from that because I didn't go to that many concerts. In fact, hardly any. Now, jet airplanes are at about 150 decibels. Way too high. But guess where I served for 1 year in the Navy? On an aircraft carrier. And guess where my rack was, where I slept on the aircraft carrier? Directly below the flight deck, in the upper bunk even. And I put earplugs in my ear when we were having night operations. So I have large ear canals, and most of the time they fall out during the night. They didn't have the spongy ones like they do today that fit very snugly in there. These are hard rubber, and I never could get them to stay in. I wonder if that's not why I have hearing loss. I don't know. Table 14.2, which is in your text, intensity levels for different sources. A nearby jet aircraft, 150 decibels. Right below the flight deck, not far from that. Okay. Jackhammer machine gun, 130 decibels. It still does a lot of damage. Guess what one of my jobs was before I was on the aircraft carrier? I was the gunnery officer. Boo hiss. Another place where you got way too high decibels. A siren at a rock concert, or a rock concert, 120. That's the level for pain. A subway or power mower, around 100 decibels. I've mowed the yard all my life, okay? I've never been on the subway that much. Busy traffic, around 80. Vacuum cleaners, around 70s. I've got to tell my wife I can't do that anymore. Normal conversation, around 50. Mosquito buzzing, oh, that irritating sound, that's around 40. Whisper, that's about 30, if you could hear me. Rustling leaves, maybe 10, and the lowest you can hear is that threshold of hearing. Okay, and it says multiplying a given intensity by 10, now these were decibels, adds 10 decibels to the intensity level. So when you go up by 10 here, in numbers like from a vacuum cleaner to busy traffic, you went up in decibel only 10. What did that do to you? Intensity? You multiplied by 10, not added 10, multiplied by 10. That's what a log scale does for you. It takes a big number and reduces it to a small, but when you're going the other way, small increase here is a big increase there. All right. Example 14.2, again, something worth your looking at. We'll see later if we can go back and do some of these. I don't know if we're going to have time. We're going to start with 14.5 next time. That'll be next Wednesday, 14.5. Let me give you or suggest to you some homework exercises you can do. On page, again, this is a really long chapter. We made decent progress tonight, but this is a really long chapter. Okay. The homework problems that you can take a look at, make sure I got it right. Yeah, we did 14.3 and 14.4. We did 1 and 2, but there weren't any problems there. Any of the odd problems, 1 through 9, that's from 14.3. And I would say just stop there. Okay? You can do some of the others, but let's do the spherical and plane waves before you do those. Okay? So if you have a chance, try to do a few of those odd numbers 1 through 9. And these are for your benefit. You don't have to turn them in, but if you can't get the answers in the back of the book, ask me in class and we'll go over those. Okay? Good deal. I know we're not quite at 9, but we're at 8:50, so I know we probably should go to 9, but let's call it quits, okay? I know y'all don't have your books yet, so let's not go any further so we don't get any further. Now, let's just talk about next time. I think we will finish the chapter next time. Doing the lab, I've never done a lab on sound because we've never done this. This wasn't called for before. So what I'm guessing your lab is going to be is probably a paper lab. In other words, I'm going to find a lab and then take some questions out of it and some things, and I'll try to come up with something getting close to 25 points worth and do that. If I can't get enough, then we may do some of the conceptual questions or problems. We'll figure it out. But the lab next time, I'm guessing we'll be in time for a lab. For the last hour and a half, we'll probably try to do just a paper lab on sound, because I don't think we have the equipment to actually do a handheld system lab. Now, if nothing else, I might look up on some of the online labs and see if I can find something that'll be good there. So I'll try to get something, and we'll get those to do for next time. Good deal. Looks like it's going to be a good class. If you know any of the people who are missing, see if you can get them here, especially if you know any that haven't paid that are missing. Be sure to get those that paid and get them here. Take care. We'll have a good Memorial Day weekend. Hey, Ray.